Good evening, students. Let us start learning about problems on friction. We'll be doing a problem as you can see here. Two blocks A and B of mass 30 kg and 40 kg respectively are connected by means of a bar placed on an inclined plane as shown in the figure. If mu is equal to 0.5, calculate the value of theta required for the motion of the block to impend. Please understand the block to impend, motion of the block to impend. So this is the diagram where you can see block A and block B, which is having a kg of 30 and 40 as the weight of each block, which is allowed to slide on a inclined plane, which is at an angle of theta. We are supposed to calculate what is the value of theta. So what is the possibility of the block to move, whether it will move up or move down? We have to understand that is block to impend. Definitely the blocks will move down. The block will move, motion will be down. The moment of the blocks will be down. And given mu is equal to 0.5. So for this, we have to draw the free body diagrams. How many free body diagrams we may come across? We'll come across two free body diagrams since there are two blocks. So let us understand drawing the free body diagram of block A. First, we'll draw the free body diagram of block A. Free body diagram of block A. Okay, the free body diagram of the block A. This is block A. I'll redraw the diagram. So you find an inclined plane at an angle of theta, right? And this is the block A. And for this, I'll drop a reference axis. I'll change the color of the pen so that we can understand the axis line. This is x-axis and this is y-axis. Correct? So now I will drop the mass or the weight of the block. Weight of the block, which is 30 kg. Convert this 30 kg into Newton, 30 kg into 9.81 Newton. Okay, and by geometry, if this is the angle theta, eventually by geometry you find this angle also to be theta. Now, what is the motion direction? How this block is moving? It is sliding down the plane. The motion in this direction. So eventually you find the direction of friction as F1 in the opposite direction, and you find the normal reaction N. Okay, this is the free body diagram of the block A. But keep in mind, students, the two blocks have been connected by a spring or a bar. It is a bar, right? So I have to indicate the force acting in the bar. So this is the bar, right? I can take any direction of the bar. Tension in the bar as T. This is the tension in the bar. Now we'll draw the free body diagram of block B. So free body diagram of block B. One thing you should keep in mind, students, if you draw the free body diagram, definitely you can solve the problem. So this is very important, drawing the free body diagram. So I'll draw the plane once again. Correct? So I'll represent the block. So block A, so block B is here. Correct? Now I'll drop the axis. I'll drop the axis. Correct? This is the axis along the plane and perpendicular to the plane. So the force, or sorry, what is the load or the weight of the block B? Block B is weighing 40 kg. So this 40 kg will be here. Exactly vertical, 40 kg into 9.81 Newton. I'll convert this. And by geometry, this is theta. Eventually, even this angle will be equal to theta, correct? And you see this is a connectivity. The block A and B are being connected by the bar. So the tension acting in this direction, eventually the tension will be in the other direction. So in the opposite direction, I can mark this to be T. Both are equal. Both are equal and opposite. Hence the bar is in equilibrium. So definitely even the motion of this block B is downwards. So we'll indicate the friction as F2 and N2. Why I'm indicating as F2 and N2 and F1 and N1? Because there are two different surfaces. It is meeting at two different surfaces. Though the plane is the same, surfaces are different. Okay. So now we have to I'll slide down a little bit. Yeah. Now we can draw the write the equations of equilibrium for the block A. First we'll write the free body diagram. Sorry, equations of apply equations of equilibrium for the block A. For the block A. Okay. So at first I'll write the equation. What is the equation we have? The equations of equilibrium taken at sigma h is equal to 0. That is all right side moving forces positive, all left side moving forces negative. So I'll write the equation now. So what is the equation? I may get it as, when I resolve this, 30 cos theta, correct? Resolving this 30 into 9.81. Sorry, I missed 39 into 9.81. The weight of the block A, 9.81. I'm resolving. So this will be 90 minus theta. This angle will be. So again, I'll be writing, I'll change this. This will be 90 minus theta. Okay. And it is negative. It is moving to the left when I resolve it. Then what else you find? Plus T moving to the right side. Then plus F1 equals to 0. Correct? So, or I can put it in the other way. T is equal to 30 into 9.81 cos 90 minus theta, correct? Minus F1. I call this as equation 1. Equation 1. Okay. Similarly, I'll apply equations of equilibrium. Sigma B is equal to 0. Okay. I'll take upward moving forces positive, downward moving forces negative. Okay. Now I'll drop the equation as a minus 30 into 9.81 into sine of 90 minus theta. Then what else you find along vertical? Along vertical you find plus N1 plus N1 plus N1 is equal to 0, or N1 is equal to 30 into 9.81 into sine 90 minus theta. Okay, then I'll go with the next equations of equilibrium to the block B. Apply the equations of equilibrium to the block B. Okay, there again I'll take it as sigma h is equal to 0. All right side moving forces positive, left side moving forces negative. Okay, then I'll go back to the diagram. I'll look for once the direction of the forces. So minus T, then you find Any other forces? No. You find the weight of the block. So I'll take it as minus T. Weight of the block is also minus 40 into 9.81 into cos 90 minus theta. Okay. And the force F1 will be equal to, sorry, F2 is equal to 0. Okay. Or I can call it as T is equal to minus 40 into 9.81 into cos 90 minus theta plus F2. I call this as equation as 2. Equation 2. Okay. Now, see, similarly, you can see here, 2 equations are taken up, right? Fine here. Same thing, we get it on multiplying and all that, doing it and substituting for N2. N1 and N2. Similarly, we have to do for the next equations of equilibrium. Sigma V is equal to 0 and moving up positive, moving down negative. So give me the equation. You get it as minus 40 into 9.81 sine 90 minus theta, right? Plus N2 is equal to 0. Now you have N2 is equal to 40 into 9.81 into sine 90 minus theta, right? So upon solving equation 1 and 2, we get the value of T as equating value as T as in the form, or we can equating both the equations, we get theta is equal to 14.4 degree because T LHS are both the same, right? F2 I'll be substituting in terms of mu value I'll be knowing. What is F2? How do you relate? F2 mu2 is equal to F2 by N2 and mu1 is equal to F1 by N1. Okay, upon substituting the values, we calculate and we get theta is equal to 14 degree. Okay, fine. Thank you, students. Hope you follow the session. Thank you all.